Example 11.1. In this example, a heavy car plunges into a lake during an accident and lands at the bottom of a lake on its wheels. The door of the car is 1.2 meters high and 1 meter wide, and the top of the edge of the door is 8 meters below the free surface of the water. The goal of the problem is to determine the hydrostatic force on the door and the location of the pressure center. We also need to discuss if the driver will be able to open this door. In order to analyze this problem, we're going to draw some assumptions. First, the bottom surface of the lake is completely horizontal, and the door is treated to be vertical and rectangular. Also, the passenger cabin is well sealed, therefore there is no water leaking into the cabin, and we could assume that the pressure inside of the cabin is atmospheric. Let's start the analysis by applying variables to the values that are given in the problem. Let's start with S, which is the depth of this rectangular shape, and is equal to 8 meters. The height, which is equal to B, is going to be equal to 1.2 in this case, and A, which is the width, is equal to 1 meter. The first step is to calculate the hydrostatic force, and that is going to be equal simply to the average pressure times the area of the surface. So let's calculate the average pressure, and that is simply going to be rho g hc, which is the distance from the top of the surface to the centroid. Since it's a rectangle, the centroid is located right at the middle of the rectangle, which means that is 0.6 meters from the top of the car. And if we add the 8 meters from the surface, then the value of hc is simply going to be 8.6 meters. So now let's calculate the value of the pressure average. And we're going to take water to have a density of 1,000 kilograms per meter cubed. The density, and then now the gravity is 9.81 meters per second square. And we're going to use 8.6 as the value of hc. Once again, is the height from the surface to the centroid of the area we are evaluating. And this gives us a value of, for the average, of 84.4 kilonewtons per meter square, which is the same thing as a kilopascal. Once we have the average pressure, we can calculate the hydrostatic force by multiplying it by the area. So we take that the hydrostatic force is going to be equal to 84.4 kilopascals, and then we multiply by the cross-sectional area of the section that we're evaluating, which is a rectangle, and it's going to be 1.2 meters times 1 meter. And this gives us a force of 101.3 kilonewtons. Let's now calculate the pressure location, and that is given by the formula YP, and is equal to YC plus IXX of the particular section divided by YC times A. The value of YC in this case, because the surface is completely vertical, the value of YC is equal to the value of HC. For our case, is equal to 8.6 meters. IXX for a rectangle is equal to A b to the third divided by 12, where A is equal to 1 meter and B is equal to 1.2 meters. If we substitute those values into this equation, we obtain a value of 0.144 meter to the fourth. And then the last part that we have is the area, and the area is equal to A times B, and that is going to give us 1.2 meters squared. We substitute all these values into this equation, and that tells us that the value of the pressure location is equal to 8.61 meters. Let's now talk whether or not a person that is inside of the cabin could open the door if he has this amount of pressure acting on the door. In general, a person could lift or could move about 100 kilograms, which is equivalent to about 1 kilonewton. So let's call this FB as the force of the person, and let's round it up to about 1 kilonewton. And this is the force that is being applied into the door at this moment. Notice the difference on the forces. But now let's see if we could actually swing it. The force that is being applied is right on the centroid in the x-axis. So the amount of moment that this force creates from the hinges is going to be equal to 101.3 kilonewtons. And the distance from the center to the hinge is going to be somewhere about 0.5 meters. That tells us that this particular force is going to have a value of 50.6 kilonewtons per meter. And let's see if we are able to apply a force. If we're trying to open in this door, we're going to do it from the handle or the farthest point away from the hinge, which is about 1 meter. So let's see if we can calculate the moment that is created by the person. And if we do 1 kilonewton times 1 meter, notice that that is about 1 kilonewton per meter. And once again, notice the difference between the moment that is created by the force of the water and the force that the person could create. It's about 50 times bigger, the amount of the force that the water is created. Therefore, unfortunately, the person will not be able to open the door when the car is located at this particular depth. The lower the depth, the higher the force that is going to be created by the water. If the car were higher, there will be a possibility that the person might be able to open the door, since the amount of the force will be also reduced.